brute full assist in that delay. So Vulkan is an API created by the Kronos group. Kronos is responsible for OpenGL, if you've never heard of it. Also OpenCL and a couple of other things. But Vulkan is a cross-platform API, specifically for the acceleration of 3D rendering. It is also capable of GPU compute, things like GPU, machine learning, etc. But basically, Vulkan provides a couple of things that allow you to integrate with an OS and then do some other things. The very first thing that you have to do with Vulkan is create an instance. I like to use the debug extension and the Mesa layer because it draws really nice. But sometimes you don't have the Mesa layer because you're on Windows, Linux, running Intel's drivers. You can do debug callbacks. It's got amazing validation support, unlike OpenGL or DirectX 11 and before. DirectX 12 has it, instead you do window initialization. Basically, the rule when integrating with an OS is to let someone else do it. So Qt, for instance, has integration with Android, iOS, well not iOS, Android, Windows, Linux, a couple of things. Once you've created your instance, you can go ahead and create a physical device. A physical device, you have to enumerate all the ones on the system. A physical device is the GPU. You have to check the properties. One of the things, the reason that you enumerate these is because different GPUs have different capabilities. I'm not going to get into it. So logical device is the actual interaction of your program with the driver. Once you've created a logical device, if that succeeds, you are wonderful, you're good to go, you can start creating your swap chain. A swap chain is the concept of when you draw on a program, you have multiple different frame buffers that you render into so that you can flip them out as they go. We need to not do that. So swap chain images are the things you actually draw into it. A swap chain image is the OS provided buffer, basically the thing that you load up to do the direct OS integration. These are the images, they're handles that the GPU uses to write to. Except things aren't that simple, because in Vulkan, any interaction with an image on the GPU from a shader has to be done via a swap chain or an image view. And the swap chain image view is the swap chain's version of the image view. Now, you can also attach different things to the swap chain, for instance, a depth buffer, a stencil buffer, or multi-sampling. Depth buffer is like, if you ever see flicker between two 3D objects, that's Z buffer finding or depth buffer finding. Once you've dealt with that, you can create a render pass. A render pass is simply what your rendering operation is going to look like when you call that draw frame function. Then you create a frame buffer. And a frame buffer is the OS interaction side of integrating with the swap chain. So the frame buffer is that little spot on the window that you get to draw to. And basically, if you resize the window, you have to recreate everything from the swap chain to the frame buffer, and it's a real pain in the ass. Now, synchronization primitives. Vulkan provides fences, events, and the semaphores. Semaphores are GPU to GPU, fences are GPU to CPU, and events are supposed to be CPU to GPU, but they're deprecated because no one knew how to use it right. So, when you want to put something on a GPU, you create a device, memory, and you create a VK buffer. And this is effectively the same thing as creating a pointer and doing malloc into that pointer. Of course, destruction happens a different way, don't worry about that. So then you can create command pools, because you need to create a command pool, which is like a driver provided heap space so you can generate command buffers. And command buffers happen to be sort of like a serialization target that you use to record different commands. So if I give you a list of commands here, no one's going to remember them, don't worry about it. If you ever actually care, you're going to just look them up on your own. And then, once you have your commands written, you can submit your commands. There's two kinds of commands, primary and secondary. Secondary commands you can record from anywhere, on any thread, you got to do it right, and then you can take them all and shove them into a primary command. Once you've done that, you can submit all your commands and present the frame. And presenting the frame, sometimes you have to do weird things like send it through transitions of layouts and formats and getting in screen space and sending it from one GPU to another. Oh, now you're an expert! And I didn't talk about actually writing shaders, so don't worry about that. That's another 5-minute presentation.